we have a function generator generating a sine wave, and we're displaying that sine wave on the oscilloscope. So this is a digital oscilloscope. It has two channels. It has channel 1, which is the yellow channel, and channel 2, which is a second channel, which you can turn on by pressing the buttons. So if we press 1 twice, it'll go off. Press it back, it comes back on. Press the blue and it goes off. Now you can see that this sine wave is just scrolling across the screen. That is due to what we call a trigger setting. So over here on the right hand side we have the timing functions, and this is the trigger level knob, and if you bring the trigger down it will trigger and give you just one. It'll effectively capture the sine wave. Now this menu keeps popping up. To get rid of that, you can press this bottom button down here. So this is a sine wave, and we want to read this. Now right now you can see we actually have multiple cycles of this. We really just want to see one cycle. You usually can't, depending on the frequency, you end up getting 1.5 cycles. But what we want to do is adjust our time knob so that we get about one to two cycles on there. And we can adjust the position. As I mentioned in class, you can actually adjust the position of the sine wave so that it crosses at a certain point. Okay. So now this trigger knob is triggering in the center. You see up here it says T, that's the trigger point, and it's triggering when the sine wave goes up. Okay. Now if this trigger level here, if you set the trigger level right at 0, sometimes when it's noisy the sine wave will kind of move on you. So you normally want this trigger level to be up above the noise. The other thing is sine waves always start going positive. They don't start going negative. So what you can do is over here on the menu button of the triggering, you can set that to trigger on the falling slope, because the way this scope works is it sets the trigger into the center. So you actually want to set it to the falling, or you can adjust the trigger all the way over to the edge. All right. So, but as you can see here, now we're showing a sine wave, and the ground point of that sine wave is this little flag or this little marker over here. That shows you where ground is equal to 0. You can also view that by pressing this. You see it says DC coupling, so you can do what's either called DC coupling, ground, or AC coupling. So if you just do ground, you see that that just shows you where 0 volts is at. And you can actually, using this knob here, we can actually raise our ground reference point or lower it. So normally we'll want that right at the center. Sometimes, depending on what you're doing, you might want something else. But we typically want that ground to be right there in the center of the scope. And then normally we'll use AC coupling. And so you use this large knob to select. You can scroll up and down with the large knob and then press the button. Alright, so we want to be able to capture an entire waveform. So it's crossing 0 here, and it's not quite getting back to 0 at the other side. So what we want to do is adjust the time so we get at least one complete waveform. Then what we want to do is we want to move this so that this waveform is crossing 0 at a grid mark. That is our reference point. Now I'm going to turn on channel 2, and what you can see here with channel 2 is that channel 2 is actually leading channel 1. So channel 1 is the yellow, that's our reference voltage. Channel 2 is the voltage at I have a resistor and an inductor in here, just a series circuit, and it's the voltage across the inductor. So channel 2 is the voltage across the inductor. So the voltage across the inductor is ahead of the voltage of the source. So the voltage across the inductor is actually in front of, or crossing 0 in front. Now you can see the voltage scaling here. It's 2 volts. That's 2 volts per division. Okay. And you can adjust that so you can make it 1 volt per division. And if I do that, the yellow is totally off the screen at the peaks. So we want to adjust it so that we can fit it on there. But you also don't want to make it too small. So if you turn the voltages down to like 5 volts per division, now the waveform is so small. So what you want to do with this scope is you want to get 1 full cycle and use as much of the screen as possible. Okay. So again, you can raise the ground or lower the ground on here. Typically we want this to be in the center position. And so our ground is this large white line going through here. That's our reference point. And our volts, or volts per division, is 2 volts for channel 1 and it's 2 volts for channel 2. You can actually change it so that, like right now, it looks like the blue is almost a little bit bigger than the yellow. It's like peeking out, but I've changed the setting to 1 volt per division. Now these digital oscilloscopes have a couple of really nice features on them. One of them is this button here called measure. So with measure, what you can do is click on that and you can say, I want measurements from channel 1. And then you can pick out what measurements do you want from channel 1. Do you want to see what the frequency is? And so you can scroll up and down and you can say, yes, I want to see what the frequency is. I want to see the peak-to-peak voltage for channel 1. I want to see the RMS voltage for channel 1. And a lot of other settings that you can select here. Similarly, you can go over to channel 2. Now, there's no sense in showing the frequency for channel 2 since the frequency for this channel 2 is just being driven by channel 1, so it's going to be the same frequency. But we might want to see the peak-to-peak for channel 2, and we might want to see the RMS for channel 2. And so we can add those all to the screen here, so it'll actually read what those values are. Now this is our function generator, and our function generator, we can change the frequency of our sine wave. So you see right now it's 10 kilohertz. You see the decimal point, so it's 10 kilohertz. Now this dial here will actually allow us to dial up or down the frequency. Now, right now I was just dialing it up based on 1 kilohertz at a time. But if I use these arrow keys, you see how I can move the decimal point left or I can move the flashing 0 left or right. And so I can dial it up at like finer values by adjusting it there. Or you can just punch in a number. So if you see here, there's numbers. It's kind of hard to see, but there's green numbers here. 1, 2, 3, 4, 5. So we have all these green numbers, and you can press the green button that says enter number and then just type in. So let's say I want to type in 500 500, and then over here I'm going to select hertz. So I can either select kilohertz or I can select hertz. And I can press that button, And so now I'm at 500 hertz. Now what happens is that this is way slower sine wave, so I'm only seeing a very small portion of my sine wave. So what I have to do now is on my scope, I have to adjust my time knob. I'm going the wrong way. Adjust my time knob to get the sine wave, so I can get like one whole sine wave. Like I say, I've got about 2 cycles of a sine wave here, but if I go here, okay, so here I've got one complete sine wave is fitting on the screen. And so again, I can adjust this so that this sine wave is crossing 0 at this little grid line. Now notice that the blue voltage is much smaller now. That's because this is an inductor and the voltage has changed due to the impedance of that inductor. So the voltage is much smaller at this lower frequency. So if you notice here, the RMS of the blue is only 118 millivolts because I'm at such a low frequency compared to what I was at before. And so I can adjust channel 2 knob to make this larger. Now notice what happens here. This is saying it's 120 millivolts. Okay. And if I make it larger, you see it's 117 millivolts. All right. So if you make it really small, it doesn't read correctly. And now it's saying it's 122 millivolts because it's so small, the scope isn't able to read it accurately. So again, you want to make it fill up a large portion of the screen so that it will read more accurately. So you want like one whole sine wave. You don't want hundreds of sine waves. See, if I change my time, all right, I can get lots and lots of sine waves. You really just want one full sine wave. So you want to adjust your horizontal so you get one full sine wave, and you want to adjust your vertical so that it fills up the screen without clipping. See, now the blue's going totally off screen and it puts a question mark over there because it says I don't know what that value is. Now, with this function generator, we can have a sine wave, we can have a square wave, we can have what they call a sawtooth wave, okay? And so we can have some different types of waveforms. We'll usually just be using the sine wave. So we press the sine wave and then we can set the frequency by pressing the frequency button, and again, either entering number and typing in the number, or we can press amplitude, or not, we'll get to amplitude, but we can enter the number, or we can simply dial the frequency up or down using the dial. Right. We can also change the amplitude. Now what we're doing is changing the amplitude of the yellow, which is channel 1. That's the input that's the voltage coming out of our function generator. And so if I go to amplitude, we can see that it's 10 volts peak to peak. Okay. Now remember, 10 volts peak to peak is 5 volts peak. And you can see here it's about 3.15 volts RMS. But if you look over here, you see that it's actually saying about 9.6. Now the oscilloscope is more accurate than the function generator. So the function generator is saying I'm giving you 10 volts. Well, that might be true inside the function generator, but there's resistance in here. And so by the time that gets out of the function generator, we lost a little bit of voltage. So you always want to read the voltage off of the oscilloscope. Alright, so again, I can dial up my voltage. So if I was really looking for 10 volts peak to peak, I might have to bump my voltage up a little bit on there. Now see, I went up to 10.5, so I'm going to use this arrow and come over here so I can dial it down so I can get exactly 10 volts peak to peak on the oscilloscope. All right, so saying about 10 volts here. Now we can also add some DC. So if we do DC offset, I can press the DC. Right now I have 0 DC offset. Okay. If I go to channel 1, remember I talked about AC coupling. I'm going to flip over to DC coupling. And now what I'm going to do is I'm going to dial up my DC. And what you see is you see that yellow waveform going up and up and up. And now I'm dialing it back down, and I can actually dial it negative. So the yellow waveform is going up and down. All right. And so that is DC coupling. So I'm going to raise it up here. And so what I've done is I'm running DC, so the sine wave is now riding on top of 1.7 volts DC. So the sine wave has been raised up. But if I go back to the coupling and I change it to AC coupling, what it does is it drops the sine wave back down because it filters out the DC and shows me only the AC component. So if you look at DC coupling, you're looking at any DC voltage plus any AC voltage. But if you look at just AC coupling, you're only looking at the AC, and any DC that may be in the circuit is being ignored by the oscilloscope.